Okay, so we have put all pieces of the puzzle together. We learned how synthetic division helps us to factor polynomials that we cannot factor by using our techniques that we learned back in Chapter R. We learned how the remainder theorem helps us to find zeros of the functions if our remainder is zeros. And we learned how the factor theorem helps us to transform back and forth between zeros and factors of the polynomial. We did an example of all of these in the last video. I'm going to go ahead and do one more example here. The difference between the last example and this example is in the last one is it told us one of our zeros. It gave us a starting point. So factor this given that this is a zero here. In this example, it doesn't give us that information. It just says factor it. Of course, after we factor it, then to find the zeros in part B or to solve the equation when we set it equal to 0, that's going to be no big deal. We just take one extra step to get that done. So back to part A. How do we actually factor this? Well, we might think back to the techniques that we learned in the first chapter of this class, but none of those techniques address how we factor something when there's 5 terms, which we see here. So that doesn't get us anywhere. But we can remember that we just learned that we can factor things by using synthetic division. So let me go ahead and set up my synthetic division. Am I missing any terms? I'm not. So I'm going to go ahead and use the coefficients that I see. But again, I'm left with, well, what the heck do I factor it by? Now we can start randomly choosing values and hopefully we can get lucky and find one that works. Or I like to kind of cheat, as I call it, and I like to use my graphing calculator for help. We know that when we're looking for zeros of the function, that's the exact same thing as finding x-intercepts of the function. So let's graph this on our calculator and let's see what x-intercepts we have. So let me pull my calculator up, graph my function x to the 4th minus 7x to the 3rd plus 9x squared plus 27x minus 54. So I have that substituted into my y in my graphing calculator. Let's graph it on the standard window, zoom 6. And again, in essence, I'm looking for the zeros. That's going to give me the same thing as factoring it in different format, which I know is the same thing as finding my x-intercepts. Now, this is a degree 4 problem, so I really should be finding 4 zeros here. But on the graph, I see 2 x-intercepts. So this at least gives me 2 of my 4 answers. We can see that negative 2 is an x-intercept, and we can see that positive 3 is an x-intercept. If you don't trust the graph, if you think it's trying to mislead you, you are more than welcome to check it, push your trace value, and type in what you think. I think negative 2 was an x-intercept. That confirms it because my y value is 0. And I think that 3 is an x-intercept. And so that confirms it. That gives me a y value of 0. So I am looking for 4 zeros in this problem. My graphing calculator just gave me 2 of them, negative 2 and positive 3. That gives me a starting place. I can choose either one of these values to figure out what to divide it by. Both of them will work one and the same. When I ask students which one to use, they usually start with the positive one, so that's the one I'm going to start with here. But just note that the other one would work the same way. Let's go through my synthetic division. Bring down my first digit, multiply, add. Negative 7 plus 3 gives me negative 4. Multiply, 3 times negative 4 gives me negative 12. Add, 9 minus 12 gives me negative 3. Multiply, negative 3 times 3 gives me negative 9. Add, 27 minus 3 gives me 18. Multiply, 18 times 3 gives me 54. And so when I add negative 54 plus 54, that gives me a remainder of 0. I'm guaranteed to get a remainder of 0 here because my calculator confirmed that this was an x-intercept. So if you used an x-intercept on your calculator and you ran through and you got something other than 0, you need to go back and figure out your work. So other than just confirming that 3 is a 0 by using synthetic division, what did we actually do here? Well, we factored. So let's figure out what this factors into. We do that by using the division algorithm, where my divisor times my quotient plus my remainder is equal to the original problem. So I had my original polynomial, x to the 4th, minus 7x cubed plus 9x squared plus 27x minus 54. I factored it. My divisor comes from this guy here. If c is a 0, then x minus c is a factor. That's what the factor theorem said. So if 3 is a 0, then x minus 3 is a factor. So that gives me my divisor. Now my quotient. My quotient comes from this here, but 1 degree less. We started out with a degree 4, so this starts with degree 3 and then just keeps descending. So this gives me a 1x cubed minus a 4x squared minus a 3x plus 18. So I have factored my polynomial by one factoring step. I took out my x minus 3, and that leaves me with this here. But I know that I want to factor this completely to give me all 4 of my zeros. I cannot factor x minus 3 any farther, but I know I need to factor this here farther. It has 4 terms. We can try and factor it by grouping, but I can tell you it's not going to work out because my groups aren't going to match. So what do we do if it doesn't factor by grouping? Well, now you can factor it by using synthetic division. And it's nice because if I have it set up like this over here, I can set up another synthetic division right underneath of it. So if you ever have to do more than one synthetic division, it's nice because you can just keep working from the last one. Well, what do I divide it by? Well, we already used our calculators to figure out our zeros. We used the 0 of x equals 3, so I would cross that off the list. I would use your other 0 of x equals negative 2. So if you used one 0, move on to the next one. So I'm going to use my 0 of negative 2. And let's go through this synthetic division. Bring down my 1. Multiply gives me negative 2. Add gives me negative 6. Multiply gives me 12. Add gives me 9. Multiply gives me negative 18. And if I add, I get a remainder of 0, which we were guaranteed to do so because the calculator told me that this was an x-intercept or a 0 of the function. So what did we do here? We took this polynomial and we factored it into your division algorithm, your divisor times your quotient plus your remainder. My divisor comes from this right here. If negative 2 is a 0, then x minus my negative 2 is a factor of my function. And the other piece comes from this down here. I start 1 degree less. This one was a degree 3, so this one's going to start with degree 2. So this gives me x squared minus 6x plus 9. So I have factored it one more step, but I want to factor it completely. So I just copy down my x minus 3. Let me simplify this to give me x plus 2 and ask myself, can I factor this by using my old school techniques? And I can. It's a trinomial in descending order, so I just unfoil it. X minus 3 times x minus 3. I should come up with 4 factors here because this was a degree 4 problem. So I have really factored it as far as I possibly can, other than I can condense it a little bit. I see this x minus 3 3 times, So let me simplify it as x minus 3 cubed times x plus 2. So in part A, when it asks us to factor completely, we have this answer here. Now, in part B, it asks us to find the zeros, or it asks us to solve the equation when our function was equal to 0. Well, we can do that by just setting each step of this function equal to 0. I'm going to take it from this step here. I have x minus 3 equal to 0, and in fact, I have that 3 times, so that gives me 3 is a solution 3 times. So x equals 3, and then I'm going to say multiplicity 3, meaning that answer is an answer 3 times. My other factor was x plus 2 equals 0, so that gives me the solution of x equals negative 2. So in this problem, we knew that we should be looking for 4 zeros. On the calculator, it looked like we came up with 2 of them, but in fact, we actually came up with all 4 because one of them was a duplicate. So I had 3 as a 0 3 different times, and then I also had a 0 of x equals negative 2. So we have done everything that we wanted to do in this problem. We factored it, and we found all the zeros. So now you can see again how all these puzzle pieces fit together to give you what you're looking for and how to factor polynomials that don't factor using the techniques that we learned back in Chapter R.